So we just got done going through combining functions using addition, subtraction, multiplication, and division. We're going to go through now and do something called the composition of functions. It's called the composition of functions. Okay, so composition of functions is a little bit different. So I'm going to take those same four functions, okay, function f, g, h, and s, but we're going to do what's called the composition of functions. So the symbol for composition of functions is what you see right here. It's just that little open circle right there. So it looks kind of like a multiplication sign, but it's not. And what it means is the way you say this, you say f of g of x. So that's the way you say it. But what it really means is this, is if I'm taking the composition of f of g of x, it really means I'm going to take the inside, I'm going to take x and plug it into g. We consider it to be the inside function. And whatever answer I get back out, g of x, I'm going to plug that into f. So x goes into g, and then I take my output from g and I plug that into f. That's the way that works. So let's find out let's take these two functions. They're the same two we used up above. Actually, they're not quite the same. They're a little bit different. But let's find what is f of g of x. This is an important side note. You'll see this in a second. The order you do this in is really important. Okay. The first function, right, f, it's always the outside function. The second function is always the inside function. So what I'm going to do is start with my set of points. I have to start by I have to plug the number into g first. So I have to look for the input of g. I can plug 1 into g, 2 into g, 3 into g, and 4 into g. So let's just start with 1. So I'm going to go f of g of 1. Which really means this, and I think it makes more sense when you write it this way. It really means f of g of 1, which means I put 1 into g first. So let's go up here. If I put 1 into g, I get 0 back out. So I put 1 into g, I get 0 back out. So now I take my output, which is 0, my output of g, and I plug it into f. So come put 0 into f, and I got 3 back out. So f of g of 1 is equal to 3. Right? I plugged 1 into g and got 0. I took 0 into f, and I got 3. So if I want to make a list of points here, f of g of x, right? When I plugged 1 in, that was my first input, I got 3 back out. Okay, let's do the next one. Let's plug 2 in. So I'm going to go, what is f of g of 2? Okay, so again, that means to take f of g of 2. So I start by plugging 2 into g. Whatever answer I get back out, I plug into f. So if I plug 2 into g, I get 3 back out. I take 3 and plug it into f, and I get 7 back out. So I plug 2 into g and get 3 back out. I plug 3 into f, and I get 7 back out. So f of g of 2 is equal to 7. So come back up here, let's add that. I know when I put 2 in, I get 7 back out. Okay, let's keep going. Let's go f of g of, our next one is 3. So f of g of 3. And I'm getting these inputs just by looking at g and looking at what my inputs are, what my x values are. So again, that means to go f of g of 3. So start by plugging 3 into g. Well, I plug 3 into g, I get 5 back out. Plug 5 into f. And okay, now we got a problem. I come back here to plug 5 in for f. There is no 5. Okay, that means that f of g of 3 does not exist. So this is a little bit tricky when you're looking for the, for the input. You got to find numbers that you can put into g. So for example, I put 1 and 2. That their output is also an f, right? When I plugged 1 in, I got 0, and I had a 0 up here. When I plugged 2 in, I got 3, and I had a 3 up here. Now when I plugged 3 and I got 5, there is no input of 5. I can't put 5 into f, and so that doesn't work. So I would not add that to my f of g of x. Okay, but I do have one more value. We do have 4 here, so I'm going to do f of g of 4. Sorry, it's supposed to be an open circle there. That was terrible. Let me fix that. So f of g of 4. Okay, so I'm going to do f of g of, I forgot my 4 there, of 4. Okay, so plug 4 into g first. When I plug 4 in, I get 2. So then I got to plug 2 into f. Come up here and plug 2 into f, and I get 4 back out. So when I plugged 4 in, I got 4 back out. Come back up here, I get 4, 4. Okay, so that is f of g of x. So composition of functions, again, what it means is you're taking you're plugging something into the first function, and then you're taking its output, and you're plugging that into the second function. Normally, when you with a lot of these combinations, like when you add or multiply, it doesn't matter what order you do these in. It would matter with subtraction or division. With compositions, it does matter. Normally, you will not get the same thing back out if you reverse it. So f of g will not be the same thing as g of f. So let's take just a second. I'll show you g of f, and then we'll do it with the two equations also. So let's go down to the second one, and I'll leave that top one up there so you can see it. So let's come down here. Now I'm doing g of f. So I'm doing g of f. Again, that's supposed to be an open circle there, and I'm struggling with those. So it's supposed to be g of f of x, which really means this, right? It really means g of f of x. So now I'm going backwards. I've got to start by plugging x, my domain of f in. So come up to f, I first have a 0 right there. So let's plug 0 in. When I plug 0 in, I get 3 back out. So I'm going to go g of f of 0. So when I plug 0 in, I get 3 back out. Take the 3 now and plug it into g. So I take the 3 and plug it into g, and I get 5 back out. So that's going to be my first point, is when I plug 0 in, I got 5 back out. Okay, my next thing, I can plug 2 in. So let's plug 2 into f. So it's going to be g of f of 2. So I plug 2 into f. See, when I plug 2 in, I get 4 back out. Plug 4 into g, and I get 2 back out. So I plug 2 in, and I got 2 back out. Okay, next one is 3. Plug 3 in. So g of f of 3. When I plug 3 in, I get 7. I come down here. There is no 7 in the domain of g. So my output from f, 7, it does not exist down here. What that means is you cannot plug 3 in the g of f of 3. So this does not exist. I do have one more number there I can plug 4 in. So let's do g of f of 4. So plug 4 into f. You get 5 back out. Plug 5 into g. Hey, there is no 5 in the input of g, so it doesn't exist either. So that's a little bit tricky, is you can only use the domain of the inside function. You can only use parts of the domain where there's an output in f, where that happens. Now this looks a little bit different with equations, so let's look at equations. Let's go down and look at h of s and s of h, so you can see both of those down here below. Let me just get this out of the way here. Okay, so let's start with that h of s. And again, I think it's really helpful for me, for the way my brain works, and working with students, this is what I see works a lot for them also, is I would always start out by rewriting it. So if I have h of s, I would always write it as being h of s of x, always. I think in our brain that just works a little bit better. But now I'm not plugging a specific number in. Okay, I'm just taking what is s of x. Well, let's look up here. S of x is equal to 2x plus 1. So now I have h of 2x plus 1. And now we've done this before. I just need to take that 2x plus 1 and come up to h. Everywhere there's an x, I've got to replace it with a 2x plus 1. So I'm going to go 2x plus 1 squared plus 3. So really what I did is I took the one function, which is 2x plus 1, and I plugged it inside of, in place of the x in the other function. And you could multiply that out if you wanted to. If it asked you to simplify it, you should multiply it out. If you do need to multiply it out, just remember, 2x plus 1 squared, we need to go 2x plus 1 times 2x plus 1. Or there's a shortcut if you remember. I'm just going to do it this way. This would be 4x squared plus 2x plus 2x plus 1, and we still have the plus 3. Sorry, plus 1 plus 3. That would be what? 4x squared plus 4x plus 4. So that is, this is the same thing, right? This is just having it work out. That is what h of s. So h of s is equal to 4x squared plus 4x plus 4. Okay, that's what it comes out to. Now, if I ask you to find this, what is h of s of 2? Right? You can just take 2 and plug it in up here. What is h of s of 2? Well, that'd be 4 times 2 squared plus 4 times 2 plus 4. You just work that out. What? 2 squared is 4, times 4 is 16, 8, 4, add that all up. What's that, 28? So h of s of 2 is equal to 28. Now, if you didn't have that equation already, and I just asked you to find this, you could just go like this, plug 2 into s. If I plug 2 into s, 2 times 2 is 4, 4 plus 1 is 5. So I take my output, which is 5, and plug that into h. 5 squared is 25 plus 3 is 28. Exactly the same answer. So if they ask you to find h of s of x, you're always going to come up with an equation, right? That's going to be your answer. And then if they ask you to plug 2 in, great, just plug 2 in there. If they don't ask you to come up with the equation, though, you can just plug the number in from the beginning. Plug 2 into s, get my output, plug that into h. Going that way. And just remember, composition doesn't always work the same both ways. Let's keep that answer, and I'll show you what happens when we do s of h. So you can see what we end up when we do it that direction. So if I do s of h, again, we're going to write it this way. So we're going to go s of h, which we know really means s of h of x. That's what it's talking about, right? First function goes on the outside, second function goes on the inside. Well, that means we're going to go s of, and we know what h of x is. It's x squared plus 3. Right? That's what h of x is equal to. Now take x squared plus 3 and come up here, and in place of, we're going to come up to s, and in place of the x, in place of the x, we're going to plug in that x squared plus 3. So I'd have 2 times x squared plus 3 plus 1. And that's my answer. Again, if they ask you to simplify it, you would just distribute that 2 through the 2x squared plus 6 plus 1. So s of h is equal to 2x squared plus 7. Okay, that's what it works out to be. Okay, so big idea here, composition of functions, right? We've added and subtracted functions. We multiplied and divided in that previous video. In this one, the composition, you're taking the two functions and combining them together by taking, you take the domain of the inside function, you plug it in, you take those outputs, and you plug it into the outside function. So you're taking the inside function and plugging it inside of the outside function. Now, let's talk about range and domain for a second. This is something that can be a little bit tricky. We're going to skip past this graph one. There is one really similar to this in the homework assignment that I'm going to show you. So we're not going to worry about that right now. But let's talk about the domain of these combined functions. This first one says the domain of the functions f plus g, f minus g, and f times g just consist of all the numbers x such that x is in the domain of f and g. So if you're adding, subtracting, and multiplying, all you do is what's the domain of f, what's the domain of g, and their combined functions has to be, the domain has to be both in f and g, has to be the domain of both of them. That's what I mean by up here. If you remember back to those sets of points, right? The domain of f was 2, 3, and 4. The domain of g was 1, 2, 3, and 4. We only include the part in the domain that's true for both of them. So they both have 2s, they both have 3s, they both have 4s. We do not use that point right there if you're adding, subtracting, multiplying, and dividing. If you are, or sorry, I said adding, subtracting, multiplying, dividing. If you're adding, subtracting, you're multiplying. If you're dividing, there's one other thing we have to worry about, is we have to make sure that the denominator does not equal 0. So we're going to say it's all the numbers, okay? So all the x values that are in f and in g, as long as g does not equal 0. So remember that one up above. I'll see where my two functions. x squared plus 3 and 2x plus 1. So I have, if I have that 2x plus 1, if I know it's on the bottom, right? This function, you can plug anything you want in. It's all real numbers. You can plug anything you want in there also. But in this part right here, if g is on the bottom of the fraction, if it's f divided by g, we've got to make sure that the g does not equal 0. So I just say, hey, I know that 2x plus 1 cannot equal 0, just like we've done before. You solve that, you get x cannot equal a negative 1/2. So really for adding, subtracting, dividing, multiplying, it's pretty straightforward. You just look at the domain of f plus g has to be the domain that's in both, has to be in f, and it also has to be in g. Okay, if whether you're adding, subtracting, multiplying. And then one thing to remember with dividing, same thing, other than when you divide, you have to make sure that you don't get a 0 on the bottom of the fraction. Now the tricky part is the composition of functions. And what you have to make sure of is two things. Is remember, we always start by plugging the number first into the inside function into g. So the first thing I say is it can only include numbers or inputs that work in g. So it has to be just the domain of g. And then what we do is we take a look at our answer. What I mean by our answer is I take a look at the final function. So when I take what does f plus g of x come out to be over here, I also check the domain of that one. Okay, and my domain of the composition has to be the domain of the inside function, along with, and it also has to be the domain of the outside function. And I'll show you what that looks like right here. So here's our example. It says f of x equals 1 over x squared minus 4, and g of x equals square root of x minus 3. So it says write a simplified form of the equations f plus g, f times g, f of g, and g of f, and then determine the domain. So let's start with f plus g. So remember, f plus g of x just means to take f of x plus g of x. Well, let's see, f of x is 1 over x squared minus 4 plus g of x, which is the square root of x minus 3. Okay. Oops, sorry. This is f plus g of x. That's what it equals. Okay, let's find the domain. So that's my answer. There's nothing really I can do to simplify that, right? I've got a square root and a fraction. I can't combine those. So that would be my answer. But let's find the domain. So the domain is simply, what is the domain of f and what is the domain of g? And we're just going to take, it has to be, the domain of f plus g has to be the domain of f and g combined together. So what I mean by that is on this first one, right, I've got a fraction. I know that the x squared minus 4 cannot equal 0. So if we solve that, right, x squared equals 4. Take the square root of both sides. So x cannot equal plus or minus 3. Okay, for g of x, we know that the inside of the square root has to be greater than or equal to 0. We've done this before, right? So if I add the 3 over... Okay, think of a number line here for my domain. I said x... Oops, I put plus or minus 3 up there. I'm sorry. Square root of 4 is 2. So I know that x has to be greater than or equal to 3. So if that's 3... right, close dot, and has to be greater than or equal to. Those are all the answers going that way. But it also can't equal 2 or negative 2. Well, that's fine because 2 or negative 2 are over here, right? You know, there's 2, there's negative 2. They're already out. I know it can't equal that, but they're already gone. So the domain for this would just be 3 to infinity. And it would be the domain of that function. Okay, let's do f times g. I'm going to do that over here. So I'm going to go f times g. So all I'm going to do is go f of x times g of x. So f of x is 1 over x squared minus 4 times g of x, which is square root of x minus 3. Okay, we're going to multiply those together. So we're going to come up here. So f times g, think of that as being over 1. So I go 1 times the square root of x minus 3, square root of x minus 3, over x squared minus 4 times 1. Okay. There's f times g. Okay, what's the domain of the function? Well, we said whether you're adding, subtracting, or multiplying, we just take what is the domain of f and what is the domain of g. And so we know we already have that. The domain of f was it can't equal plus or minus 2. The domain of g is x has to be greater than or equal to 3. And both of those have to be true. So really x is greater than or equal to 3 is the same thing. It's got the same domain. Okay, this is where it gets tricky. We're going to do the composition of functions now. So let's take a look at that. This is where I should say where the domain gets tricky. So pay really close attention to this. This is some of the, I think on your CBE, this is some of the trickier questions that you'll run into. So let's first find out what is f of g, and then we'll find the domain. So let's go f of g, which means this. Again, always write it this way: f of g of x. Okay, so we start with the inside. What is g of x equal to? Well, that's f of g of x is square root of x minus 3. Okay, now we're going to take that and plug it in for x into f. So I'd have 1 over square root of x minus 3 squared minus 4. And we can do a little simplifying there. So let's first find the domain. So this is how you find the domain. Remember, you always have to plug x into the inside function first. So I have to make sure, first of all, what is the domain of g? Always start with the inside function, always. So start with the inside function. What is the domain of the inside function? So what is the domain of g? Well, I know that x minus 3 has to be greater than or equal to 0. We've already done this. That means x has to be greater than or equal to 3. So right away, with f of g of x, I know I can only plug numbers in that are greater than 3. Okay, the second part is you have to simplify your answer and then check the final answer to see if there's any other restrictions. So let's look at that. Let's simplify. So f of g is equal to, this square and this square root are going to cancel out. So I'm going to have 1 over x minus 3. Those two just cancel each other out. I still have the minus 4. So I end up with 1 over minus 3 minus 4 minus 7. Okay, so that's what f of g comes out to be, is 1 over x minus 7. Okay, so I already checked. I know I have to plug it into g first. So I already know it has to be only numbers greater than 3. But now look at your final answer. Are there any restrictions over here? And there are, right? Because I have that fraction. I know that the bottom can't be equal to 0. So I know that x minus 7 cannot equal 0. So if I solve that, I know that x cannot equal 7. So that's going to look something like this. Let's see. We know that it has to be greater than 3. So if that's 3 right there, it has to be greater than 3. But it can't equal 7. So right there at 7, there's an open dot. So that's a little bit tricky, but you always start with, what is my inside function? So the inside function was g of x, what's the domain of it? And then you look at your final answer, what's the domain of that? And then it has to be true for both of them. So you have to combine those two together. So I'd write the final thing, I'm going from 3 to 7, union, and then I'm going from 7 to infinity, going that way. So in other words, it could be anything bigger than 3, greater than or equal to 3, as long as it doesn't equal 7. That's tricky. Let's reverse it, and let's switch it around, and now do the g of f. I know this video is getting a little bit long, but I think this is important to see. I think this is the trickiest part of your assignment, is when you go back and try to find the domain of these composition of functions. What happens sometimes is we try to do it like we did the adding, subtracting, multiplying, which I just find the domain of the first and the second, and that's not the way we do it. You start with the inside function, what's the domain of it, then you find your answer, and then you check your answer, your final simplified answer, to see if there's any other restrictions. Okay, so let's do g of f, which we know means g of f of x. So start with your inside function. G of f of x is 1 over x squared minus 4. Okay, then take that, the 1 over x squared minus 4, and plug it in for x up here for g. So I get the square root of 1 over x squared minus 4 minus 3. Okay, that's my answer. I don't know that we're going to be able to simplify that even. But let's see if we can figure out the domain. And this is going to be a little bit tricky, but we'll get it. So we're going to start always with the inside function. When I plug a number in, it first has to go into f. So start with, what are the restrictions on f? Well, we did that up above. We did that already, right? We said x cannot equal positive or negative 2. So that's part of my domain. I know that x can equal positive or negative 2. The second part is, are there restrictions on my final answer? Well, that's a square root. I've got to make sure that inside does not, has to be greater than or equal to 0. So I go 1 over x squared minus 4 minus 3. And this is going to end up being a big pain. There's nothing like this on your assignment, so hopefully don't let that stress you. In fact, to solve this inequality, we have to do something that we haven't done yet, and there's nothing like this on your assignment. So I think I'm going to stop here with that just because, again, to solve a rational inequality, though we have to require some stuff that we haven't done yet, we'll do it later on, and you don't have anything like this on your homework assignment. So I'm not going to finish that off, but what we do is we'd solve that inequality, and then we combine it with this up here to get our domain. So you always look at what is the domain of the inside function, find your answer, that's my answer, and what's the domain of that answer, and then you combine those two together to get the domain of the entire function. I'm going to go through some problems from your homeworks, but I think I'll do that as a separate video. So I'm going to stop this one. I'll pull up some problems from your homework assignment, and then we'll go through some separate problems. Thanks, guys.